Okay, welcome to the Advanced Orthogonal Table Placement section. This is where you'll have the refinements of joint influences applied in the art of chiropractic utilizing the Advanced Orthogonal procedure. Most techniques talk about the science, philosophy, and art behind chiropractic. Well, with so much science being placed on the X-ray analysis, the vector calibration, and the instrument impulse for the adjustment, the art application of our procedure is applied in our table placement influences. The theory behind table placements is that the patterns of misalignment help us conceptualize how the biomechanics should work. The theory behind our table placement protocol is that the patterns of subluxation help us to conceptualize how the biomechanics should be working. These patterns are taken from the X-ray factors, which are done by drawing the lines, taking the measurements, and looking at stick figures that we'll be going over to help us get a better broad-based perspective as to how the overall biomechanics exist in that person's misalignment. And the X-ray factors are translated into the patient's positioning aspects of table placement. First, we're going to observe how the stick figures will be used in our classwork understanding of the misalignment components of subluxation. We have our line going through the skull, represented in green, our line going through the neck, represented in red. We have a blue wedge going through our atlas as our atlas frontal plane, and we have a yellow triangle representing our axis spinous. The frontal cephalic line in green was drawn through the skull using our zoning procedure. The atlas frontal plane line is the blue wedge found through our majority rules system. Our cervical spine line was drawn on our X-ray analysis. Our axis spinous was drawn at the tip of the C2 vertebrae, C2 spinous. Our atlas rotation around the y-axis is being denoted here by the right atlas being moved anterior further away from us, and the left atlas mass being posterior, coming larger as it comes towards us. Our upper angle is formed between the frontal cephalic line and the atlas frontal plane line, and it's called the ACD, atlas cephalic displacement. So as you can see in the box on the right hand side, the larger of the wedge, the taller portion, is the posterior represented atlas mass, and the smaller wedge is represented as the anterior atlas mass. There are two primary patterns of subluxation. One is referred to as a contralateral pattern, and the other as an ipsilateral pattern. Here we have our typical contralateral pattern, where the ACD upper angle and the cervical spine acute lower angle are on opposite sides from each other. The C2 spinous will typically rotate away from the closed C1-C2 joint, thus meaning that the C2 spinous is misaligning towards the ACD side. And because C1 and C2 tend to misalign in conjunction with each other, the atlas goes anterior on the side of the ACD as well. The atlas frontal plane line will typically be above level. In our second pattern, we have where the ACD and cervical spine are forming acute angles on the same side. Same side is the phrase ipsilateral. A typical ipsilateral pattern will not only have the acute angles of the upper and lower angles on the same side, but because the C1-C2 joint is closing on the side of the ACD, the C2 spinous will typically rotate away from the closed C1-C2 joint, thus moving to the side opposite the ACD. And as C1 and C2 misalign rotationally together in a typical scenario, the atlas will misalign posterior on the side of the ACD, anterior on the side opposite the ACD. And the atlas frontal plane line is typically below neutral. So if you were to observe each of these 5 stick figure examples, which of them would be considered a typical contralateral pattern? So take a moment and pause the video till you decide which one is the typical pattern. The answer is number 4. When we look at our number 1 example, you can see that the wedge stick figure of the atlas frontal plane line is larger on the right-hand side, thus showing a posteriorly misaligned atlas on the side of the ACD. With the C2 spinous rotated towards the ACD, this would indicate a counter-rotation misalignment of C1 and C2, which is not typical to the contralateral pattern. In the second example, the C2 spinous is rotating into the closed C1-C2 joint, which is atypical. In our third example, the C2 spinous is also rotating into the closed C1-C2 joint. And in our number 5 example, the atlas is posterior on the side of the ACD, which is atypical to the pattern. Our number 4 shows the contralateral cervical spine compared to the ACD, with the atlas anterior on the right, posterior on the left in this example, and the C2 spinous going away from the closed C1-C2 joint. If we were to look at the ipsilateral patterns, pause the video and look to decide which is a typical ipsilateral pattern. The answer is number 3. If we were to look at each of these examples, example number 1 has the C2 spinous misaligning into the closed C1-C2 joint. Pattern number 2 has the atlas rotating anterior on the side of the ACD, which is atypical for an ipsilateral pattern. Example number 4 has the C2 spinous misaligning into the closed C1-C2 joint. And pattern number 5 has the C2 spinous also going to the C1-C2 joint, as well as the atlas being anterior on the side of the ACD, atypical to an ipsilateral pattern. So the correct answer is number 3, where the upper and lower angles are acute on the same side. The C2 spinous has misaligned away from the closed C1-C2 joint, and the atlas is posterior on the side of the ACD. Dr. John Grostic said every atlas adjustment can be positively or negatively affected by table placement. And Dr. Sweat went on to say 60% of the atlas subluxation correction is the result of correct table placement. So if over 60%, more than half, of the actual correction of the atlas subluxation is the result of correct table placement, this adds credibility for the importance of mastering the dynamics of joint influences in table placement protocols. So let's get to it. Here are the patient positioning steps and X-ray factors for which those steps are applied. We'll begin with proper mastoid support stabilization. We will then put the patient into a neutral spine position. We'll then set the headpiece height and then the headpiece angle, and we'll influence the shoulders in a superior-inferior position as well as anterior to posterior position, rechecking to restabilize the mastoid. Table placement step number 1 is a mastoid support. This is by far our most important step in table placement because an unstable mastoid will not allow for stable condyles under which we can slide the atlas in the correction. The mastoid first should be placed in the middle of the headpiece and about 3/8 of an inch up on the headpiece from the base of it. We're going to angle the headpiece till the mastoid catches, which is essentially matching the shape of the mastoid. If you were going to err, you would rather err on opening up the headpiece angle a little too much rather than not enough. When we look at the different shapes of these mastoids, you can see here that the mastoid with a flatter shape would have a flatter stabilization of the headpiece angle. As the mastoid is more curved, we would increase the headpiece angle to match the curve. And if the mastoid is extremely curved, we would very much increase the headpiece angle to match the curvature shape of the mastoid. Now, which of these mastoid shapes is the correct one? All of them. That is typical genetics, normal genetics for that patient. It's our job to customize our table placement to match the patient's genetics as well as their subluxation components. Our second step is our neutral spine. The ACD determines which side the patient will be adjusted on. The shoulder opposite the ACD is placed on the table, and we will be adjusting them from the side of the ACD. If the patient's ACD is on the left, then the patient's right side will be placed on the table, left side up. When observing genetic anomalies of the condyles, it's important to denote that the CACD, the correctable ACD, which includes the aberrant condyle analysis, trumps the ACD, especially when the CACD changes the side of laterality. The neutral spine line is determined by measuring a straight line going up from the T7 mid-thoracic spine through the lower cervical spine C7 up to the EOP. When those three are in line, then the patient is considered to be in neutral spine line position. The shoulders should be placed perpendicular to the neutral spine line. So you would observe the tips of the shoulder being 90 degrees to the neutral spine line to start with. You would want to ensure that the shoulders are not rotated. This is accomplished when both shoulders are in line with the trunk of the patient. The shoulder touching the table would have a slight anterior aspect of the humerus showing, and a slight winging of the scapula on the side the patient's lying down on. So in this example, her right anterior humerus should be slightly more anterior than her left shoulder, and her right scapula would wing ever so slightly more posterior compared to her left one, because her body weight is going to cause a slight compression of her shoulder girdle, making the shoulder blade flare. Our third step is headpiece height. When we're measuring our x-rays and assigning a plus or minus value to the atlas as it sits above or below the horizontal level, if there's a +1 to +5 millimeter atlas frontal plane line measurement, we're going to raise the headpiece till the EOP is up to 1/2 inch above the neutral spine line. If the atlas frontal plane line measures +6 to +9 millimeters, we're going to raise the headpiece till the EOP is 1 inch above the neutral spine line. And if it's above 10 millimeters, we're going to raise the headpiece till the EOP is up to 1.5 inches above the neutral spine line, and that's as far as we go. If we go further, we take the risk of jamming up the joints with too much structural influence being applied in the table placement that would disallow for the bones to move correctly as the sound impulse enters into their structure. If we have a lower AFP, then we will lower the headpiece. A -1 to -5 millimeter AFP would cause us to lower the headpiece height till the EOP was brought down to 1/4 inch below neutral spine line. And if the AFP is -6 millimeters or lower, then we will lower the headpiece till the EOP is down to 1/2 inch below the neutral spine line. We wouldn't want to go lower than 1/2 inch because it tends to destabilize the mastoid support as we lower the headpiece down further than that.